everyone, welcome back to Easy Taleem. In the last lesson, we learned how to split algebraic fractions when the denominator contained distinct linear factors distinct linear factors or repeated linear factors. Those were the easy cases, right? Now we are going to change the rules. Suddenly our one constant is going to become bx plus c instead on in the numerator of one of the fractions. Now and then we are also going to study that why that the fractions that are too large to decompose, and finally we'll see why partial fractions is not the end of the story. It becomes useful in series and then later connects beautifully with binomial expansion. And Cambridge also tests students on this topic along with binomial expansions most of the time, like 90% of the time. So today we are finishing partial fractions once and for all. Okay, so now tell me, so this is a small recap from our last lesson on partial fractions. Can I decompose this? Can I factorize this? So yes, of course, you can. And how do we do that? We rewrite it as a upon 2x plus 1 plus b upon x minus 3, and then you multiply the entire right hand side and left hand side by the denominator on the left hand side, so that this becomes 2x minus 13 is equal to a times x minus 3 plus b times 2x minus 1. And then you are going to make a few substitutions intelligently. So first is going to be x is equal to 3 in order to give you a value of b, whatever that's going to be. And then you are going to make another substitution across the equation of x is equal to minus half in order to so that your b vanishes and you can easily find the value of a, whatever that may be. Now the second thing that we did was repeated factors. And how did we do that? We decomposed it into a upon x minus 4. The second one would be b upon x minus 4 whole square. And the third one was c upon x plus 3. Again, we are going to make a few substitutions intelligently. The first one is going to be x is equal to 4, so before doing that, we are going to multiply the entire both the sides by the denominator on the left hand side, so that this becomes 2x minus 11 is equal to a times x minus 4 x plus 3 plus b times x plus 3 plus c times x minus 4 whole square. And now we are going to make those intelligent substitutions. The first one is going to be x is equal to 4, which is going to make our a and c vanish, and we can find the value of b. And then we can find the value and then we can make a substitution of x is equal to minus 3, which is going to make a and b vanish, and we can find the value of c. And then we are going to and then we can use the easiest substitution besides these two, which is going to be x is equal to 0, and we are which is going to and we are also going to plug in the values of b and c that we found earlier using intelligent substitutions in order to find the value of a, and therefore this fraction would be decomposed into partial fractions. Okay, now we will now move on to that where does this quadratic fractions come from and factors come from, and how do we decompose those quadratic fractions. Okay, now let's see, how do I decompose this? So I can see that the numerator is of degree 2 and the denominator is of degree 3. So in the denominator we have a cubic polynomial decomposed or factored into a linear factor and a quadratic factor. Can I further factorize x square plus 2? No, because x square is going to be equal to negative 2, which has no real solution. Therefore, this quadratic stays exactly as it is. Now, if I cannot split this quadratic, how do I split the fraction? Now, this is where Cambridge is going to change the decomposition. Now, do I rewrite this above as 8 plus 2x minus x square upon x minus 1 times x square plus 2? Can I rewrite this as a upon x minus 1 plus b upon x square plus 2? This is wrong. Okay, so this is absolutely wrong. Now the correct version of this is going to be a upon x minus 1. This is degree sorry, this is degree 0, this is degree 1, a linear factor in the denominator, so a constant in the numerator, plus a quadratic factor of degree, so a degree 2 polynomial in the denominator, so a degree 1 polynomial in the numerator, which is going to be bx plus c. Why? I'll show you why we do that. So this is going to be similar to 8 plus 2x minus x squared, because we want to see all the maximum possibilities in order to obtain a quadratic factor in the and I'll show you how. So this is x minus 1, this is x squared plus 2. Now when I multiply this entire left hand side and right hand side by the denominator of the left hand side, this is going to become 8 plus 2x minus x squared is going to be equal to a times x squared plus 1, which is quadratic, plus bx plus c times a linear factor. So linear factor times a linear factor is also going to become a quadratic, right? So while students just formalize, just memorize these formula, I want you to understand it. So there is only one rule: the numerator must always be 1 degree less from the denominator. Okay, then its denominator. So for example, if the denominator was degree 1, like here, the numerator was degree 2, which was a constant. So if a denominator was of degree 2, then the numerator is going to be of degree 1, which is bx plus c. Now if the denominator is going to be of degree 3, then the numerator is going to be quadratic, which means that it's going to be a polynomial of degree 2. That's the entire pattern. You're not memorizing formulas, you're recognizing degrees. Now let's try to solve it. So if so I multiplied this already, so now I can use substitutions intelligently. So this is going to become I can now use x is equal to 1, which is going to give me 8 plus 2, 10, 10 minus 1 is 1, 10 minus 1 is 9, 9 is equal to a vanishes, and okay, so I cannot use x is equal to 1, that, oh wait a second, oh, this other one is x squared plus 1. Sorry, I made a small mistake here. This was x squared plus 1. So now the second bracket vanishes and I get 1 plus 1 is 2. If I'm using, sorry, this was x squared plus 2. My bad. I made a small error. This was x squared plus 2. So this was x squared plus 2. As you can see here, here, right? So this was x squared plus 2. So now this becomes 3a. So my a is now going to become 3. Now I can use another substitution from here, which is going to be, I can use so now this is going to become 8 plus 2x minus x squared is going to be a is 3, so this becomes 3x squared plus 6 plus bx squared minus bx plus cx minus c. Let's correct the like terms, okay, and then we are going to make comparison. So this becomes 8 plus 2x minus x squared, and this becomes is equal to 3 plus b times x squared minus b plus, so this becomes c minus b times x, and then the last one is going to be 6 minus c. Now the constant is going to be 8, so 6 minus c is equal to 8, therefore c is going to be equal to negative 2, and 3 plus b is the coefficient of x squared, so we can compare it to the coefficient of x squared on the left hand side, and we put the identity sign here. So this is negative 1, so my b is going to be negative 4, right? So that's the answer, okay. And that's it. So finish. Now what changed? Only the final step before, but everything before that remained exactly the same. So now how do I decompose it? I'm going to write the value of a, b, and c here in the decomposed version of this quadratic, this fraction. So this is going to become, so this thing on the left hand side can be rewritten as 3 upon x minus 1 plus the value of b and c is b is minus 4, c is minus 2. So I can take this common, minus sign common. So my b is 4 and c is 2. So 4x plus 2 upon, minus sign is in between, upon x squared plus 2. Okay. So this is how you are going to do it, right? Now, so this leads us, so I hope this is clear. I would encourage that you guys go to your Cambridge endorsed book and try a few questions from the exercise. I think this is chapter 7 of further algebra. So you must do their section. I think this should be 7b or 7c, 7c probably, in which they're covering quadratic factors. So go through the description in the book as well, and also attempt the exercises and check your answers from the back. If you have any queries, you can, as I told you earlier, you can reach out to me on my WhatsApp free of cost, +92 329 3028 and you can also follow us on my Instagram channel, which is by the name of Easy Taleem, EASYTALEEM. Now let's now move on to improper fractions, where the power in the numerator is the same as the denominator or one above, right? We are going to do the case where the degree of numerator and denominators polynomials are exactly the same. Now let's look at this this fraction, 2x squared plus 5x minus 11 in the numerator and x squared plus 2x minus 3, another quadratic in the denominator. Now can we immediately start partial fractions? And the answer is no. Why? Now look at the degrees. This is degree 2 polynomial, this is degree 2 polynomial. So this fraction is improper, and before partial fractions, Cambridge, before you partially factorize it, Cambridge expects polynomial division, and this is exactly why we studied polynomial division before factor theorem and partial fractions. The order wasn't really random. Okay, now if I do a long division on this is going to become, I put the numerator inside this long division, 2x squared plus 5x minus 11, and I put x squared plus 2x minus 3 outside of it, and now I try to divide it. So I divide this, sorry, what is happening? So let me use another one and make it bolder. So I divide this by this, so I get a 2. Let me change the pen. So 2, so this becomes 2x squared plus 4x minus 6, and I put negatives, and so this becomes positive. This cancels. 5x minus 4x is what? It's just x, and minus 11 plus 6 is minus 5. So like I told you earlier, so if this is 35, this is 8, so 8 times 4, this is 32, the remainder is 3. So we can rewrite this 35 upon 8 as what? So this is 3, so 4 times 4 whole 3 upon 8, right? Or you can also rewrite it as 4 plus 3 upon 8, right? So this comes here. So the remainder is going to... No, what am I doing wrong here? So basically, x squared, so 2x squared plus 5x minus 11 may be written as 2 times x squared plus 2x minus 3 plus x minus 5. Okay, now if I have to divide this entire thing by this divisor, x squared plus 2x minus 3 and x squared plus 2x minus 3, so I'm going to get 2x squared plus 5x minus 11 over x squared plus 2x minus 3, and now I can split it using the plus sign here. So this becomes, so this cancels with this, so this becomes 2 plus x minus 5 over x squared plus 2x minus 3. So I'm going to use my remainder here, right? And okay, so this is exactly what we were doing earlier as well, that this was 4 plus 3 upon 3. So quotient plus remainder upon divisor. Divisor was 8, right? So this was equivalent to 35 upon 8, right? So this is exactly what we have done here as well. So now this may be rewritten as 2 plus this, and now I can rewrite it as 2 plus x minus 5 upon this may be rewritten as x squared plus 3x minus x minus 3, and so or this may be rewritten as 2 plus x minus 5 upon, what are the two factors? X plus 3 minus 1, so x minus 1 and x plus 3, and then instead of trying to decompose this version, you just have to decompose this proper fraction, right? So now this becomes x minus 5 upon x minus 1, x plus 3 may be rewritten as a upon x minus 1 plus b upon x plus 3. Use the substitutions intelligently. So this becomes x minus 5 is equal to a times x plus 3 plus b times x minus 1. I hope you have seen my lecture, the partial fractions lecture 1 of this series. This is part 2 of 2, right? Now I use substitutions. So x is equal to minus 3 and x is equal to 1. When I put x is equal to minus 3, my a vanishes. So this is minus 8 is equal to minus 4b. So b is going to be 2. And when I put x is equal to 1, b vanishes. So this becomes minus 4 is equal to 4a. Therefore, a is going to be equal to negative 1. So instead of a, I'm going to put negative 1. And instead of b, I'm going to put 2. So I can rewrite this as 2 plus 2 upon x plus 3 minus 1 upon x minus 1, and that's it. Okay. Now so once we converted, so after we performed the long division, we got a polynomial, we got a proper fraction in this form, right? We got a constant outside, and then we factorized the denominator here, and only then did we perform partial fractions. So this is one of the easiest marks to lose. Many students skip the polynomial division, which you must be very well versed in. We did a lot of practice in our lesson, in our last few lessons. This is the 5th video in the series of Algebra 9709P3. The examiner immediately knows that the student does not recognize an improper fraction if you fail to perform this long division and find this constant 2 and write it separately here. Okay. Now, why did we spend 2 entire lectures on partial fractions? What was the purpose of doing that? Just to split fractions? No, the chapter continues. Now, if you have, let's say, 1 upon x times x plus 1, so we can decompose it into 1 upon x plus, a upon x plus b upon x plus 1. And if we try to, I know the answer to it already, so we can rewrite this as 1 upon x minus 1 upon x plus 1. Now, suppose Cambridge asks you, what is 1 upon 2 plus 1 upon 6 plus 1 upon 12, which is basically you're plugging in the values in here, right? So these terms begin cancelling. This is called a telescoping series, but they're not going to ask you here, right? They're going to ask you to expand this up to the term in x squared, let's say. So since you cannot just make it x squared plus x and then put it into x squared plus x and put it power minus 1 and start doing it, so a better approach is going to be that you first split this into 2 proper fractions partially, and then this is going to become x to the power minus 1, or you just leave it like this, 1 upon x, and then you start x plus 1 to the power negative 1 and you expand the series. But this is for our next lesson. So now in the exam, your first question, as soon as you in the question paper, as soon as you see this a question on partial fractions, ask yourself if you can factorize if the factors in the denominator, whether they are distinct and linear or linear, distinct linear or repeated linear or quadratic. They usually are not going to give you cubic, or if the entire fraction is improper. And how do you identify if the entire fraction is improper? When the degree of polynomial in the numerator and in the denominator are the same, right? So first you have to identify this, and then you have to choose the correct decomposition, right? So we have done quite a few of them. We did one for distinct linear, we did one for repeated linear, we did one for quadratic factors in the denominator, which was bx plus c upon x square minus 1, for example, x square plus 1, because if it is x square minus 1, then I would just split it into x plus 1 and x minus 1. And for improper, we have to first perform the long division, get a constant out or get a remainder out, and then convert it into a proper one, and then you break it into partial fractions. So after you have correctly identified the decomposition form, then you solve it. Students who identify the case correctly usually solve the question and get all the marks. This is as per all the examiner reports that we always go through. Students who choose the wrong decomposition, they never recover. So what are going to be today's takeaways? We did linear distinct decomposition, we did repeated linear decomposition. So linear distinct is a upon x minus 1 plus b upon x minus 2. Repeated linear is what? It is a upon x minus 1 plus b upon x minus 1 whole square plus c upon x minus 2. And then there is quadratic. So this is going to be of the form a upon x plus 2 plus b upon plus bx plus c upon x square plus 1, for example. And then for improper ones, you have to first perform the long division, which is absolutely necessary, right? So you have to do the polynomial division first for those. So partial fractions is not the end, it leads directly into applications. So now in the next lesson, we finish the entire algebra series with one of the highest scoring topics in pure 3, which is binomial expansion, right? So this is going to be our next lesson, and this is important. This is tricky. Sometimes students find it tricky, but if your concept is strong and if your algebra is strong, then I don't see any point of you losing any mark here, right? In that, we are going to cover positive integer powers, we are going to cover fractional powers, we are going to cover negative powers, we are going to do approximation questions in that, and also the examiner tricks in Cambridge, right? So if you have followed this algebra series from modulus until today, you're building exactly the foundation Cambridge expects before tackling the harder pure 3 questions like differential equation, integration, other calculus stuff. Even if you're not enrolled with Easy Taleem in my course for October, November or May, June 27 series, or for retake in October, November, keep following this series. I'll continue sharing the key ideas publicly so everyone can strengthen their understanding. You can follow us you can subscribe to our YouTube channel, or you can follow us on Instagram. I've already given you my channel, which is Instagram. The handle is easy, EASY Taleem. If you have TALEEM, if you have any queries, you can reach out to me on my WhatsApp +92 329 485. You can take it down. And if this lesson helped, like the video, subscribe to the channel, and share it with a friend who's preparing for 9709 paper 3, and drop a comment. Ask me any questions on Instagram and YouTube, and hopefully I'll try to respond to each and every one of you. I'll see you in the final lecture of the algebra series. Until then, goodbye.